this mean? Jaginder. 7 times itself thrice. 7 times 7 times 7, which is 343. Now, back in the day, when you were faced with exponents, your teacher said, get out your calculator and tell me what the answer is, yes? And you all know how to use your calculator. You push 7, then you push whatever your exponent button is. Some of you have little x and a y, some of you have y and an x, some of you have this little mountain symbol, which is actually called a caret. Some of you have, and this is how lame calculators, no, I lie. This is how lame society has gotten. Your people are so bad and dumb at math that some calculators now have x with a little blank up there, because putting letters in math is confusing for people. You have one of those 4. Then you push 3, then you push equals. You can all do that. Do it for the last time right now, because you will not again in this unit use your calculator to do any exponents. Because now you're going to learn calculate exponents with variables. So it doesn't matter if you know what your calculator does, because you won't be using it. You all have done it already before. Everything I'm going to show you this year, unless you are coming straight from grade 9, then you will not have seen the very last thing we do. All right? Actually, some grade 9 teachers will not have done any variable bases. It just depends on the teacher. So, I assume that kids come here with no knowledge of exponents and start from scratch. Okay? Let's do it. That is what we are talking about. What there is the base? Jaginder. The 7 is the base. I'm going to highlight the base in yellow. I'm going to highlight the word base in yellow. Base is what? Don't say the big number. What is the base? And don't say 7, because I already know it's 7. Tell me what a base means. Don't give me an example. Well, you all told me you understood what this was. So what's the base? Don't say number, because it might not be a number. Could be a variable. The base is the expression which is multiplied. Now, what do I mean by that? That's what's going to go right in this space right here. You already know that 7 cubed equals 7 times 7 times 7, right? Well, what then is y cubed? What does that mean? Say it loud and proud, Zook. Y times y times y. I used to use x there, but when I wrote xxx, everybody would giggle. So I've made it yyyy now. Everybody cool? Because y is not a number. You don't know what y is. Y is an expression. Everybody good? Okay, I'm going to change it slightly. I'm going to change it slightly. X plus 2 cubed. What does that mean? It means x plus 2 times x plus 2 times x plus 2. Whatever is down there is repeated that many times. That is the base. It might be a variable. It might be an expression. It might be a number. It might be 3 or 4 numbers put together that you then take that whole result and put it to an exponent. Does everybody understand what the base is? Okay, it's the expression which is multiplied. Where does the base live? The base, and I'm going to do that in blue, is anything. Because it might be a number, it might not be. Anything immediately left of an exponent. Now, please notice I ended this definition with the next word we're going to define, which is exponent. What is it? The 3. What does that mean? That is the number of multiplications. Where does it live? It is what we call a superscript, which means it's written above the line. Anytime you see something written above the line, it's an exponent. Does it have to be a number? No. In future math, you are going to be dealing with things like this. Don't write this down. 10 to the x. You don't know how many times 10 is going to multiply. And there's math to figure that out, but not till grade 12. So for right now, the exponent is always going to be a number, except in a couple of weird questions, and you'll see what I mean when we get there. Everybody cool? All right. The whole thing is the power. A power is a base and an exponent. And we read it as base to the exponent. I forgot some letters there. Exponent. So this is 7, the base, to the third. If it's a 4, it's 7 to the 4th. If it's a 5, it's 7 to the 5th. You already know this. But I am repeating it because you often, kids your age, don't do very well on this particular section. Some have special names like 3. Anything to the 2 is squared. Anything to the 3 is cubed. Then nothing else gets a special name. Everyone else is just stuck. All right? Now you are going to fill in this chart below here all by yourselves. I'm going to show you what I mean for the first one. Actually fill it in. You're all going to fill it in. You're all going to fill it in perfectly. And then we're going to go into doing some actual exponent work. And you're all going to do great. And then I'm going to say, now you do it by yourself. And then you're going to be like, and you're going to start screwing up. Even though you're all going to do all this perfectly, you're going to forget that if you can do this, you can do everything. All right? So I'm going to do the first one with you. You're going to work on the rest. Here is the first one. Fill in every blank. 2 to the 4th. What's the base? 2. What's the exponent? 4. So what does that mean? That means 2 is going to multiply how many times? 4 times. 2 times 2 times 2 times 2. Which is? What's 2 times 2? 4 times 2 is 8 times 2 is 16. That's all you got to do, okay? Fill that in. If you think it's all going to be that easy, you're a little wrong. You've got to use your brain. Right with the very second one. Go. Because we were talking about gummy bears. Damn, son, that was the hardest one. You probably could get 15 gummy bears. I'll give you 7 now. Still no? You finish the chart, I'll give you 7 gummy bears. No? Okay. Is it you don't like gummy bears? Oh, is that what it is? Have you tried a frozen gummy bear? Well, then. All of you have taken your gummy bears and put them in the bank. You have not tried a frozen gummy bear. Once you eat one frozen gummy bear, you will never go back. You will go to Save on Foods. You will buy a bag of gummy bears. You will put them in your freezer. Because they are so much better. We'll see. What's the base here? I could do this by just asking Jay Ginder every single box here, right? And then you would have filled it in anyway. No. Negative 5. Why is this one negative 5? Sihaj. Because it's in the bracket. Right? Exponents 2. So what do I write here? It's bracket, negative 5, and then negative 5 again. Negative and a negative gets me a positive. This one, 8, 5, 8 times 8 times 8 times 8 times 8. And this is about literally the last time you will do this on your calculator. You will do 8 with your exponent button and 5. And I think it's like 32,000 something. But I don't remember. It's like 32,768 or something. Yeah? Okay. What's the base? 6. How many times it repeat? So what's the power? 6 to the 5th. And what's the answer? 7,776. This one's tricky. What's the base? Negative 1, because the negative repeats every time. Right? How many negative ones are there? 7. So what's the power? Is it that? Or is it that? It's that one with the red. You have to have the negative. Now, what's the answer? Negative 1. Because negative, 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 an odd amount of times means it's going to be negative. 10(3). How do I write it? 3. What do I write here? 10 times 10 times 10, 1,000. X cubed. Uh-oh. What's the base? X. What's the power? 3. And this is the first time everyone's going to giggle. X times X times X. What's its value? X cubed. Why? Because it's not a number. You have no idea what X is. X could be 7,000. X could be 0.1. You don't know. So its evaluation is whatever the base is cubed. You cannot tell me. This one's really tricky. How can I have a positive base, a positive exponent, but still get a negative number? The negative has to be outside the brackets. Negative 2 to the 5th. So this is 2 times 2 times 2 times 2 times 2, which is 32, but it's all negative. Everybody get that one right? Okay, why do I have two different ones here? How many ways are there to use exponents to get 9? How? What's one way I could do these? I could do 3 and 2 and get 3 squared, yes? Because that would be 3 times 3. Is there another way I could use 3's to get positive 9? I could do, that should be red. I could do negative 3 squared, which would be negative 3 times negative 3, and still get me 9, right? What would the base be here if I was doing the red one? Negative 3. Is everybody cool? Is there a third way I can make 9 with exponents? What? Not to the power of 0. 9 to the 1. 9, 1. 9 doesn't repeat, and I get 9. Everybody cool? Now, in your knowledge right now, that's the only way you can do this. But by the end of this unit, you're going to know a whole bunch more ways to use exponents to get 9. Everybody cool? All right. This one's super tricky. What's the base? Negative 4. What's the exponent? So it's negative 4 6 times, yes? So an even number of negatives means my answer will be what? Positive. But there's a negative out in front. So what's my answer? Negative. And it is negative, and I think it's 4,096. And the last one, base is 4. What's the exponent? 1. We never write 1 as an exponent because what's the point? 4, 4. Does everybody remember how to do this? Everybody can do this with numbers, yes? Every single one of you have seen this, even the grade 9s. Who are not grade 9s anymore. I know, you're grade 10s now, but you know what I mean. All right, turn the page over. In order to do exponents, you have to know 7 things. That's it. You only have to know 7 things. A great many of you have more than 7 things in your head right now, which means you are capable of learning 7 things, which means you should have no trouble getting an A on this section, right? Because this section tells you what to do. Multiply powers of the same base. Okay, if you were in the 9th grade and you paid attention, you at least did this. 2 squared times 2 cubed. What does that mean? 2 times 2, 2 squared, times 2 times 2 times 2, 2 cubed. How many 2's is that? 2 to the 5th. 2, 3, 2, 2. 2 plus 3 is 5. Done. Right? You all already know this. In the 9th grade, that's all you had to learn. Hopefully your 9th grade teacher said, yeah, but in grade 10, we're not going to have numbers there. We're going to have letters there. And hopefully your grade 9 teacher taught you this. X to the A times X to the B. Same base. The answer is X to the A plus B. Hopefully your grade 9 teacher taught you that. What does that mean? Exactly the same thing as it means with numbers. X squared times X cubed is X times X, X squared, times X times X times X. You can quite plainly see there are 5 X's there. Again, if you write it out, it is impossible to do exponents wrong. It's impossible. But all of you will start going to all these shortcuts and not learning what they actually mean, and you will get all confuzzled in your brain with when to do which shortcut. You don't take shortcuts until you actually know how to get somewhere, right? If you move to a new town and you ask your buddies at school, the kids you meet at school, hey, how do I get to the mall? And one kid tells you, and you follow that route to the mall. Do you start changing that route halfway there? No. You follow that route until you know exactly where the mall is. And then you're like, oh, maybe if I go here, I might understand. Don't jump to shortcuts until you really know what you're doing. Okay? Which is why I do not understand why all your middle school and elementary teachers teach you shortcuts all the way along instead of teaching you what to actually do. Then your brain is filled up with shortcuts. Let's look at the next one. Dividing powers of the same base. You're smart kids. 2 cubed divided by 2 squared. Well, that means 2 times 2 times 2 divided by, oh, don't do this. No, you son of a... Turn you off. I'm going to turn that 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 off. Now I'm going to turn that back on. Divided by 2 times 2. Now the intelligent students amongst you, as you are all intelligent young people, automatically know that anything, when it's the same on the top and bottom of a fraction, we cancel it. Now everybody says cancel. You mean cross it out. What does it actually mean? What is 2 divided by 2? 1. What is 2 divided by 2? 1. What is 1 times 1? 1 times 2? It doesn't matter. That's what we mean when we say cancel. It doesn't disappear. It's because it divides and creates a 1. Which is why, and don't write this down, when you get to grade 11 and you get questions like this, x plus 3 over 3, you guys, because you haven't actually learned what you're doing, you all do this. Cancel. The answer is x. And that is not right. So learn what canceling really means. Okay. Then, hopefully, your grade 9 teacher, the answer is, of course, 2 to what power? The number that we never write, which is 1. And 3, 2, 1. X to the a divided by x to the b equals x to the a minus b. And again, if you write it out, you cannot do it wrong. X to the 5th divided by x to the 3rd. 1, 2, 3, 4, 5 over 1, 2, 3. 3 of them cancel, and I'm left with x squared. I don't know why this is confusing for everyone. You're all looking at me like, why are you talking to us like we're dumb? We all get this, right? I'm not talking to you like you're dumb. I'm talking to you like I know what's coming. As do most of you, because you've been through grade 10. Hopefully you didn't find this unit that difficult, but if you're like the kids I teach, you did. Everybody cool? All right. Third one. You all know how to do it. An exponent to an exponent. 2 squared cubed. What does that actually mean? No, that's what you're going to do. What does it actually mean? Two squared, how many times? 3 times. Squared, 2 squared. Which really means 2 times 2, 2 times 2, and 2 times 2. Which is really 6 2's. Hey, 6, 2, 3. As Madeline says, all you're doing is x to the a to the b equals x to the a times b. This is the first one that starts screwing you guys up. And here's why. You all understand that x squared cubed is xx 3 times. You all get that one. I don't need to show that one to you. That is x to the 6th. What you always screw up, and I mean always, is this one. 2x cubed. And we're going to leave that there for a moment. So those are the first basic 3. You should all be cool with them. Okay? The next one is the exponent of 0. Now, notice there's a bunch of white space here. Because your grade 9 teacher and your grade 10 teacher told you anything to the 0 power is what? 1. That's what they told you. Did they explain why? They should have, because what we're doing next needs you to understand what I'm about to show you. Okay? So, 3 squared equals what? 3 times 3, which equals 9. Yes? Right? Okay. 3 to the 1 equals what? 3, which equals 3. Cool? What math is happening between these two rows? Add, subtract, multiply, or divide? No, between the rows. What math is happening right there? Subtraction? Division, right? 9 divided by 3 is 3. So when I'm going down the list, I'm dividing each time, aren't I? So 2, 1, what is logically the next exponent? 0. I can't write anything in the middle here, can I? Because 3 isn't being written at all. But logically, if I divided by 3, what am I going to do here? Divide by 3. What is 3 divided by 3? 1. That is why the exponent of 0 is 1. What if I had 27 here? Well, 27 squared, then divided by 27 is 27, then divided by 27 is 1. Doesn't matter. Okay? The other reason is this. I'm going to change colors to show you another reason why this works. And I have a reason for showing you why this works. 3 cubed divided by 3 cubed. What are you supposed to do with the exponents when you divide? Subtract. So isn't that 3 to the 3 minus 3? Which is 3 to the 0, correct? Right? Well, isn't 3 cubed 27? And isn't 3 cubed 27? What is 27 divided by 27? 1. So if 3 cubed divided by 3 cubed equals 3 to the 0, and 3 cubed divided by 3 cubed equals 1, then what does that tell us about 3 to the 0 and 1? That they are the same thing as well. You need to understand that to understand the next thing that we are going to do. Okay? Well, the third thing we're going to do from now. You need to understand this pattern. Do you? All right, now, there's still some white space here because this also causes trouble. What is this value? One, because anything to the 0 is 1. What is this value? -1. What is this value? What should I write right here? 1. Because any base to the 0 power is 1. Why is this one -1? Because the negative is outside the brackets. The base is still 1, and then there's a negative out in front. Is everybody cool with number 4? I've spent a lot of time on number 4 because it's going to make number 7 make sense. Is everybody cool? All right. Now we have a couple of easy ones to help us out. 2 different bases raised to the same exponent. Well, 2 times 3 squared. Okay. Well, that is 2 squared times 3 squared, which is, what's 2 squared? 4 times 3 squared, 9, which equals 36. Now you will notice that the 2 went to both bases. 2 got squared and 3 got squared. They both got the exponent. Yes? Everybody understand? So the rule now that we use with letters, x, y, I don't know why I have an M there. That should be an A. I've been using A the whole time. Is XA, YA. The exponent goes everywhere. Everybody got it? All right. Now remember, I said this up here. This one right here was going to screw you guys up. Because 99% of you, if I give you 2x cubed, tell me the answer is 2x cubed. Is that right? No. Because of what you just learned here. What is this answer really? 2 cubed x cubed. What is 2 cubed? 2 times 2 times 2. 8x cubed. Because the 3 goes to everything. I'm going to spend a bit of time with this one because kids screw this up. Next thing I want to warn you about. Can you forget about the first 4 rules when you're at number 5? Do you think? Of course you can't. You're in grade 10, right? Can you forget the math you learned in grade 2? No, you can't forget all your previous math in grade 10. So you can't forget all your previous rules when you get to number 5. What if I gave you this? 3x squared y cubed squared. What would that answer be? This is going to make you use Rule 5 and Rule 3. 3 squared x to the 4th, because it's 2 times 2. Y to the 6th, because it's 3 times 2. Notice if you write it out, you cannot do it wrong. 3 squared is what? 9. 2 times 2 is 4, and 3 times 2 is 6. You can't do it wrong if you write it out. You can't. Everybody cool with 1 through 5? Okay, 6 and 7 is where they start getting a little fuzzy. Let's start with 6. 2/3 squared. You're smart young people. When it was 2 times 3 squared, where did that squared go? In number 5, where did the squared go? To everything. So where's it going to go here? To everything. 2 squared over 3 squared. Now some of you are going to tell me that answer, you're going to go, oh, 2 minus 2, 2 minus 2. Why are you not going to go 2 minus 2? The bases aren't the same. Whoever whispered that loud enough for me to hear it. Was it Jasneet? Jasneet, sorry. Jasneet, I'm so sorry. I have taught, in this school, there is 2 Jasneet Dillons. They even have the same middle initial. And they are in my class all the time. So I have lots of Jasneets in my life. I have no Jasneets. I am sorry. You deserve better attention than I am giving you. I will try not to do it again. But the other weird thing, guess where Jasneet D and Jasneet D sit in my room? In those 2 desks. Right beside each other. Just to piss around with me. They're also in my homeroom. So I have to give them their report cards as well. They even look a little alike. They both wear glasses. They both have the same long hair. Neither one of them ever puts it in a ponytail or anything, so I can tell them apart. And they have the same name. It's very frustrating. It's not really frustrating. I'm a grown-up. I can work with it. But it's embarrassing now because I keep calling Jasneet Jasneet. And I'm trying to avoid it. You have been very nice not to call me Mr. Martin or something. You have always called me Myers. You would think I would get my mind around your name. But same thing for Pavneet. Huh? See? All right. Can I subtract there? No, because the bases aren't the same. So what's this answer? 4/9. And what's the rule? X over y a gets me xa over ya. And again, you must remember all your other rules. So if I gave you x cubed over y to the 3rd, 2x cubed over y to the 3rd, and I said square it, what would the answer be? Two squared x to the 3 times 2 over y to the 3 times 2, which would get me 4x to the 6th over y to the 6th. And I'm done. Can everybody handle everything up to 6? All right. Now, many of you should have seen negative exponents already. Hopefully. 3 of you in grade 9 maybe haven't seen what we're about to do. But it's really easy when you think about it. Remember how I said we have to remember that pattern for why the exponent of 0 is 1. Yes? Let's do that pattern right now. 2 cubed is 2 times 2 times 2, which is 8, correct? What's logically the next row? 2 squared, 2 times 2, 4. Because at every row I divide by 2, right? Because I've removed one of the 2's from the multiply. And what removes multiplication? Division. Everybody cool? Logically, next exponent, 2 to the 1, 2, 2, divide by 2, right? Logically, next exponent, 2 to the 0, can't do it there, equals 1, because I divide by 2. Logically, what is the next exponent? 2 to the negative 1. Can I write that out? Is it possible? Take the base 2 and multiply it by itself negatively. Does that make any sense in your brain? Can you figure out how you could draw that for me? Because you can draw 2 squared, can't you? Right? 2, make a square. Oh, 4. I get it. Right? Easy. Can you draw this? Can you make me a square that will show me this? Because you can do 2 and 2 to get 4, right? You can do a cube, 2, 2, 2 to get 8. Easy peasy, yeah? Can you draw 2 to the negative 1? Yes or no? No, because it doesn't exist. 2 to the negative 1 is not a thing. You cannot explain it. It doesn't work in our universe. But it has to work in our universe, doesn't it? Because we are going down by exponents. It must work. So logically, what must this row be? I must divide by 2, yes? What is 1 divided by 2? 1/2. What is the next logical exponent? Negative 2. Divide by 1/2. If I cut 1/2 in half, I get 1/4, yes? If I cut 1/4 in half, I get 1/8. Now, all of you should be noticing a pattern. 2 cubed is 8. 2 to the negative 3 is 1/8. 2 squared is 4. 2 to the negative 2 is 1/4. So what is the rule? X to the negative a equals 1/x to the positive a. You reciprocate. Now again, this is difficult. This is where you're going to screw everything up because you're going to be looking for this shortcut. I don't want you to see the shortcut yet. I want to work a bunch of reasons why it works. If I add 2 cubed divided by 2 to the 4th, do they have the same base? Yes. So what can I do with the exponents when I'm dividing? I can subtract. What is 3 minus 4? 2 to the negative 1, which is 1/2, correct? Just like we learned in this chart. This is what I want you to see, though. 2 cubed is really 2 times 2 times 2, correct? Agreed? Over 2 times 2 times 2 times 2, correct? What gets to happen with these 3 2's and these 3 2's? They're gone, they're gone. What number has to be left up here? I can't have 0, because if it was 0, 0 divided by 2 is 0, and this is clearly not 0. This is 2 times 2 times 2 times 1, isn't it? What is left? 1/2. That is why 2 to the negative 1, another reason that it equals 1/2. Is everybody good? What if I showed you this one? 2 times 2 times 2 over, times 2. No. Hold up. Let's do it this way. 2 cubed divided by 2 to the negative 4. Is this okay? That's okay, right? That's 2 times 2 times 2, correct? Is this okay? What's wrong with this negative 4? Negative exponents can't exist, can they? Well, when the negative exponent was here, what's the denominator really? 1. Well, the negative exponent meant we did a reciprocal, yes? So what is going to happen to these 4? Saihash, say it loud and proud because you're right. They would move up to the top because the reciprocal of a denominator is a numerator, right? And I would get 2 to the 7th. Now, how can you use the shortcut here? Well, are these the same base? So what should I do with the exponents? Subtract. So it's 2 to the 3 minus 4. What's minus 4? 3 plus 4, which gets me my 7. Is everybody cool? I can't think of another way to show you why this works. But what do you take away from number 7 here? This is what you take away from number 7. Negative exponents can't exist. You have to move them. What is that word right there? Exponents. It only applies to exponents. Is this okay? Why? Because the base is negative. This is 64. What is this? 1/64. Everybody cool? What is this? Ooh. Negative 1/64th. And what is this? Positive 1/64th. Is everybody good? All right. Prove it. The next 2 pages, this page, page 15, is all work you should be able to do in your head. You should not need your calculator at all. It should literally take you 2 minutes. When you are done, break is at 10:55. I lie. Break is at 10:40. You should get these 35 questions done before that break. That's how fast this should be. When you get back, as you can see, number 3, I'm going to go on to the next thing. But then I'm going to give you some exponent practice in block 4, and we're going to go over your test. So if you finish this 35, you will look, the next pages, they get harder. 17 and 18 have some really hard ones. If you can do everything that is circled, you are good enough. You are guaranteeing yourself a C+ to a B on your test on exponents. If you want to get that A, you might want to practice a few more of them. Everybody cool? So until 10:40, 13 minutes from now, you are working on 15, 16, and 17. I'm going to have the real answers to 15 and 16 up on the screen, added to the video, and I'm going to do that in about 8 minutes. At 10:35, I'll put up the real answers to 15 and 16. You should all already be done it by the time I put up those answers. Yep. All right, done. Some of them at the bottom are a little bit hard to read. In your printing, they're not as hard to read on my screen, but some of you, it didn't print incredibly well. I do apologize, but I don't need the printing, they do the printing, and they don't appear to proofread. No, that's times. It's just the other way we write times. So sometimes you'll see some people write AXA and they'll be like, oh, that's another X. No, it's times. I'm just trying to cover all the ways it might be written. A with a dot times A, AX, A, and A bracket times A bracket. I'm just trying to cover all my bases. That's why I usually do those squiggly X's to not confuse the two. We good? Yeah, you do. Look at exponent law 3. The worst kind of law. Exponent law have 3 when it goes over brackets. That's law 3. I'm putting it all together. You can't wait 4 minutes to break. You can't wait 4 minutes to break. One more minute, then I'll put up the right answers. Actually, I'll wait. I'll put them. You'll see the answer when you get back. Yeah. $16. The only one I foresee being a problem for anybody is number 16, but I will respond to any questions you have on 1 through 16. One way that some people like to think about, for example, number 8, is they like to look at it this way, a to the 6. Well, if there's 6 down there and 2 up there, those 2 are going to be canceled, leaving me with 4. So it's 1 over a4. It's another way people like to think about it. It's totally up to you how you think about it, though. Everybody's okay with everything, including 16? Why it's flipped? Pardon me? Yeah. When you flip it, this 4 becomes positive. Everybody cool? All right. There is 17 through 28. Again, 27 and 28 didn't print very well. Hopefully you were able to see it. If you weren't, it's no big deal. As long as you applied the right exponent law, I don't really care if you have what I have, as long as you did the right thing with the numbers that you could see. Does everybody understand what I mean? Everybody understands why this is s to the 10th? Because 5 minus 5. Or you could look at it this way. That negative 5 can't be down there. So it would come up to the numerator, and then I'd have 10 s's up top. Everyone is still good? Once. Twice. Thrice. Spectacular. And there is the last 7. All right, now remember, this unit is on exponents, yes? But you cannot forget all the other math you know. For example, if I gave you x to the 3rd over x, you know that that is x squared, because 3 minus 1, right? But let's remember, what if I put some numbers out in front? What happens? What is this? Completely separate. That is 21 divided by 7, which is what? 3. So that answer would be 3x squared. What if it was this? What would it be? (7x squared over 3). You can't forget all your previous math just because you've learned something new. Right? It's just like when you're learning to drive. When you learn how to make a left-hand turn, do you forget how to make a right-hand turn? No. Stuff doesn't fall out of your brain when new stuff goes in. Okay? All right, everybody cool? All right, now listen. Again, you've got a whole block to practice exponents, because the next two things that we're doing, super easy, super lightweight. You just need to see them, okay? One of them, because it's going to become very important in grade 11 and 12, that's the real number system. And LCM and GCF is really only important because it's how we simplify radicals. And you've already done them before anyway, so I'm going to bomb through them. Then I'm going to give you a long time to practice both exponents, real numbers, and LCM and GCF. At the end of today, we'll go over this test, which needs some going over. Okay? Everybody good? All right. So, quiz 1 right here. I don't think I'm going to do quiz 1 because it's pretty easy, but we'll see. So if everybody could turn to page 19, the real number system. Like I say, this is really like a 2-second lesson, but it's important for future. So I just want to stop this for a